Hi everyone, I'm going to show you guys how to solve this MIT integral. So what you could first do is, you could factorize the polynomial you have inside the square root, right? So you have x to the power 4 minus 4x plus 3. Let's just call it as fx. So if you substitute 1, let's say, so I'm trying trial and error method. So if I substitute 1, I'll get 1 to the power 4 minus 4 into 1 plus 3. So this will give you 0. So meaning x equals 1 is a factor. So you can divide the polynomial by x minus 1. To simplify this polynomial, you could divide it by x minus 1. So before going any further, I should tell you guys that when solving these questions in the exams, you need to solve it within 5 minutes. But I'm showing you guys how to solve this question with basic integrals. So using substitution. After we break this down into smaller parts. So if I divide x to the power 4, so I'm going to use polynomial division first. So I can write it as x to the power 4 plus 0x cubed plus 0x squared minus 4x plus 3. You divide that by x minus 1. So then x to the power 4 divided by x, you get x to the power 3. X to the power 3 into x, you get x to the power 4. X to the power 3 into minus 1, you get minus x cubed. And then 0x cubed minus, open brackets, minus x cubed, which gives you x cubed. So it's basically 0x cubed minus x cubed, alright? So it's just x cubed. And 0x squared comes down. So x cubed divided by x is x squared into x is x cubed, x squared minus 1, x squared into minus 1 gives you minus x squared, right? The same way you subtract, so 0x squared minus x squared gives you x squared, minus 4x comes down, x squared divided by x is plus x into x is x squared, and x into minus 1 is minus x. So minus 4x minus x is minus 3x. And finally the 3 comes down. So minus 3x divided by x is minus 3. Minus 3 into x is minus 3x. Minus 3 into minus 1 is plus 3. So you can see your remainder is going to be 0. So therefore x minus 1 into x cubed plus x squared plus x minus 3 is the factorized format. But we could factorize this even more further, right? Because now we have a cubic term, a cubic polynomial. So x to the power 3 plus x squared plus x minus 3. So if you look at this polynomial, what factors can we take? You don't even have to do anything. You could just do it in your head. You could just try substituting 1 into x. So it's 1 cubed plus 1 squared plus 1, which will give you 3 minus 3. So you'll see 1 plus 1 plus 1 minus 3 gives you 0 when x equals 1. Alright? So again you can say x minus 1 is again a factor. So you could use x minus 1 to divide the cubic polynomial. So I'll go on to the next page. So x cubed plus x squared plus x minus 3 divided by x minus 1. You do it the same way like I did previously. So x cubed divided by x is x squared, x cubed minus x squared. Then x squared minus x squared is 2x squared. 2x squared divided by x is plus 2x. This x should come down, by the way. So then 2x into x is 2x squared. 2x into minus 1 is minus 2x. X minus 2x is 3x. The minus 3 comes down. 3x divided by x is plus 3. 3 into x is 3x. 3 into minus 1 is minus 3. your remainder is 0. So therefore you can write, so x to the power 4 minus 4x plus 3 equals to x minus 1 into x minus 1 into x squared plus 2x plus 3. Now you can see we broke it down, right? So our integral was root x to the power 4 minus 4x plus 3 dot dx, which you can write as root x minus 1. Since you have two x minus 1s, you can just put the squared, right? X minus 1 squared into x squared plus 2x plus 3 dot dx. Okay, so since you have the root, now your integral is going to be x minus 1 into root x squared plus 2x plus 3 dot dx. Easy, right? Now, what you could do is, you have a quadratic equation now, right? You have x squared plus 2x plus 3, a quadratic polynomial. So what I'm going to do is, I'm going to change that into a completing square format. So x squared plus 2x plus 3, you can write it as x plus 1 squared minus 1 plus 3. So x plus 1 squared plus 2 is equal to that. If you expand the brackets, you'll see. Okay, so now it's x minus 1 into root x plus 1 squared plus 2 dot dx. Okay, now I'm going to take a substitution of u equals x plus 1. So du over dx equals 1, right? So if u equals x plus 1, what's x minus 1? So u minus 1 equals x, right? So then u minus 2 into root, instead of x plus 1, I'm going to write u squared plus 2 dot du. Okay, now let's expand the brackets. Now we have the integration of u into root u squared plus 2 dot du minus 2 root u squared plus 2 dot du. Now these are the integrals you have to solve. Okay, so let me go on to the integration we have on the right side, because that's going to be a bit more complex than the one we have on the left side. So for the one on the right, I'm going to take a substitution of u equals root 2 into tan w. Okay, so du over dw equals to root 2 sec squared w, right? So if I take the integration here, it's root, instead of u squared, I'm going to write 2 tan squared w plus 2, right? And instead of du, I can write root 2 sec squared w dot dw. So what does this become? The square root. So you have 2, you can factorize 2 out. So it's going to be root 2 into tan squared, you'll have tan squared w plus 1. You'll have root tan squared w plus 1. So what does this give you? This gives you sec w, right? Sec w into root 2 sec squared w. Easy. So root 2 into root 2 gives you 2. So I'll just take it outside. Now you have to integrate sec cube w. And how do you do that? So I'm going to use integration by parts. So I could write this as sec w into sec squared w, right? So I'm going to take u as sec w and dv over dw as sec squared w. And now you should know the formula for integration by parts. This in terms of dw, this is the formula you have to use. So u into v. So what's the integration of sec squared w? So v equals tan w, right? So u into v is sec w into tan w minus the integration of tan w into du over dw. So we need to differentiate u equals sec w. So du over dw equals to the differentiation of sec w is sec w into tan w. Okay, so it's going to be tan w into sec w tan w dot dw. Right? So we got sec w tan w minus the integration of sec w into tan squared w, right? So what's tan squared w? You could write tan squared w as sec squared w minus 1, right? Now this would be sec w into tan w minus the integration of sec cube w dot dw, we could write it like that, plus the integration of sec w dot dw. Now this is equal, now this is basically the integration of sec cube w, right? So sec cube w dot dw, the integration, sorry I forgot to write the integration sign. So the integration of that equals to sec w tan w minus sec cube w dot dw plus the integration of sec w dot dw. So you can see that this can be taken on to the left side, right? So when you take it on to the left side, it's going to be 2 sec cube w dot dw equals to sec w tan w plus the integration of sec w dot dw, right? Easy. So how do you integrate sec w? What's the integration of that? So with this, I've shown it in one of my previous videos. It's an old video. I'll drop in the link for that. If you guys have any doubts with the integration of sec w, please go through that video. It will help you guys out. So I'm just going to write the answer straight away for the integration of sec w. The integration of sec w is ln sec w plus tan w. You could also write it as ln tan w divided by 2. You could write it either way, but I'm going to take it as this answer. So I'm telling you guys again, I'll be dropping in the link for that video. So if you guys have any doubts with the integration of sec w, you guys can go through that video. Alright, so you could write the integration of sec cube w equals to sec w into tan w plus ln sec w plus tan w, the whole thing divided by 2, because we had a 2 in front of the integration of sec cube w, right? So if you go back into your question, now we had this 2 in front, which we didn't consider, and we had another 2 in front over here, right? So we had 2 into 2, that's 4, which I didn't consider into the question, right? So then we'll have to multiply this whole thing by 4. So that would be 2 sec w tan w plus 2 ln sec w plus tan w. That's the answer for this section, alright? this section right here. The integration of that. Okay, now we go on to the integration on the left side, where you should know there's also a minus in front of the integration of sec cube w, so I'll just put in the -2 like this. Okay, that's the answer for our right section. Now we go on to the left section. So we have the integration of u into root u squared plus 2 dot d. So please tell me if you guys have any doubts, okay? Because this question it's a bit long. And I've been going through every single part. I've been going through polynomials, then integration, so you guys might get confused. So please tell me if you guys have any doubts. So for this integration, it's easy. You could just take a substitution of t equals, let's say u squared plus 2. Yeah. So dt over du equals 2u, right? So then dt over 2u equals du. Yeah. So you go into integration. U into u squared plus 2 is t dot du. Du instead of du, I'm going to write dt over 2u. U's cancel out. You have half in front. All you have to integrate is t to the power half. So the integration of t to the power half is 2 over 3 into t to the power 3 over 2. Don't forget to multiply by half. So you get 1 over 3 into t to the power 3 over 2. Okay, now let's bring in our answers together. So it would be 1 over 3 t to the power 3 over 2 minus 2 into, you see this, right? So I'm just going to expand the whole thing with minus also. So it's going to be minus 2 sec w tan w minus 2 ln sec w plus tan w. Okay, now let's put in our substitutions again. So we had the substitution of t equals u squared plus 2, right? And then we had u equals to hold on, u equals to x plus 1. So t equals x plus 1 squared plus 2. So you can write t equals to, so if you expand this, you get x squared plus 2x plus 3. Okay. Now what's tan w and sec w? How do you find that? So we had, let me just go up again. We had u equals to, so we had u equals to root 2 tan w, right? So you could write u over root 2 equals to tan w. So then what would sec w be? So sec w is 1 over cos w, right? So you could find cos w like this. You just need to find the hypotenuse. So it would be adjacent, which is root 2 over the hypotenuse would be square root u squared plus 2, right? So now, if you put that back in, you could write sec w equals to the reciprocal of that, right? So root u squared plus 2 over root 2, and you could write sec w into tan w equals to root u squared plus 2 over root 2 into tan w, which is u over root 2, giving you u into square root u squared plus 2 over 2. And you had u equals x plus 1, right? We had u equals x plus 1. If you put that in, you'll have x plus 1 into root x plus 1 squared plus 2 is x squared plus 2x plus 3 over 2. So sec w tan w is this, alright? Okay, now let's find sec w plus the tan w. Sec w plus tan w, which is this. So that would be root u squared plus 2 over root 2 plus u over root 2, right? So now you could write this as u squared plus 2 plus u over root 2. Okay, now you found, oh wait, now let's put u equals x plus 1. So when you put that in, it would be square root x squared plus 2x plus 3 plus x plus 1 over root 2, right? Now, let's go to our final answer. Alright, I'll change the color for that. So we have, we'll just write the same thing again so that you guys won't get confused. This was the answer I got with the substitutions. Minus 2 ln sec w plus tan w. Oh, by the way, don't forget your plus c, alright? So what was t? We had t equals x squared plus 2x plus 3. So 1 over 3 into x squared plus 2x plus 3 to the power 3 over 2 minus, what was sec w tan w? Sec w tan w was x plus 1 into square root x squared plus 2x plus 3. But there's a 2 in front and we have a 2 at the bottom, so you can see they'll cancel off. So you could just leave your answer like that. Minus 2 ln sec w plus tan w is, let me take it just right below over here, 2 ln square root x squared plus 2x plus 3 plus x plus 1 over root 2 plus c. This is your final answer. Alright then, that's everything for this question. So if you guys have any doubts, please drop a comment. I'll help you guys out. And yeah, if you guys like my teaching, leave a like and subscribe. It would mean a lot to me, and thank you so much. Have a great day.